And here we are at prime factorization, which basically means we're taking any bigger number and whittling it all the way down to only its prime factors. So we've learned two different ways to do this. The tree method is the method that you probably knew before this year. And you can choose any two numbers at all that multiply to give you 180, like 10 and 18. And we're going to keep breaking these down until we get to prime factors like we just did with 5 and 2. So I'm just going to circle those. For 18, we will get maybe 6 and 3, and we can circle 3 because it's prime. And finally, we break down 6 into 3 and 2, and those are prime. And once we've got all of our branches of our tree ending in prime numbers, we are done with the tree. Now, in order to write it in exponential form, that means we're going to find however many of each prime factor we have, and that's going to be our power. So, for example, my smallest prime factor is 2, and I'm going to count how many 2's I have. Well, I have 1 and I have 2, and I'm just going to kind of mark them off so I know that I've used them already. And then I have 3, and I have 2 3's, so that would be 3 to the second power. And then finally I have a 5. So my prime factorization is 2 squared times 3 squared times 5. Okay, let's do the cake method for 294 just to do something a little bit different. So remember, with a cake method, I can only divide by prime numbers. So I know that since this is even, it's got to be divisible by 2. So 2 into 2 is 1, and 2 into 9 is 4. Carry the 1, 147. So at this point, if you were not thinking about your divisibility rules, you might be tempted to say that this is a prime number. But we know better, because check it out. When we add these digits, 1 and 4 and 7, we get 12. That is a multiple of 3, which means that 3 can go in to 147. How many times does it go? Well, I don't know. Let's just figure that out. 3 goes into 14 4 times. That gives us 12. I subtract, bring down. 3 goes into 27 9 times. So 49 is my next number. Now, what is 49? That's a perfect square. That's one of those really special numbers where you can divide the same number twice, basically. So 7 times 7 gives you 49. Those are both prime numbers. And so my last layer of my cake is to get down to that candle. And so the nice thing about the cake method is we don't have to go like hunting and searching for prime numbers like we do in the tree method. They are always all right here on the left side. And this is actually in numerical order too. I can write 2, I'm going to cross that out, times 3, and then I have 7 to the second power. And so that would be the prime factorization. All right, do whatever you want to do for 396. I'm partial to the cake method. I know that all three of these are very easily divisible by 3, so I can just do that pretty much in my head. 3 into 3 goes once, 3 into 3 goes 3 times, and 3 goes into 6 twice. So now I'm at 132. I know that that is even, so I can divide by 2. 2 goes into 13. Well, let's kind of do the math here. 2 into 132, that's going to be 6. I subtract, bring down, and I get 6 again. So it's 66. And now I am going to divide this by 3. 3 times 22, and that is an even number. I can divide by 2 and get 11. And finally, this is a very big cake. I finally get down to my candle. And so again, all of my prime factors are all lined up here on the left side. And so I will have 3 to the 2 second power times 2 to the 2 second power times 11. And I hope this helps.